So now we're going to talk about weather patterns as they exist in the mid-latitudes where we live. So this week's really relevant. It actually is going to talk about systems that impact you literally daily. So what kind of systems actually shape it? Well, you've got to understand we're dealing with air masses first. We talked a little bit about modification of air masses and different things about how air masses form under high pressure. Well, these are the basic types of air masses. You can see that there are several that originate over Canada, others over the North Pacific, North Atlantic, and then down the Gulf and tropical areas. And even the continental tropical, which is a very warm air mass that can come out in the summertime that can cause you to get the 100-degree temperatures in the eastern part of the U.S. when it comes out. The key to everything in meteorology is where these air masses come together. That's what we're trying to be found. Because under the air masses, it's all high pressure. It's nice weather. It may be cold, it may be warm, but it is nice weather. All the bad weather occurs at the edge of the air mass. So with that, we've just talked about those air masses. Let's look at a stationary front. So two air masses have come together and they're not moving. What do you wind up with? You wind up with a lot of warm air to the south of it, cold air to the north of it typically. And as you can see, remember everything's three-dimensional, it slopes upward. So deeper in the cold air, the higher the slope of the colder is deeper. So you have a little bit of high clouds up there, but down lower. As you get closer and closer to the front, the clouds get lower. Precipitation would get more intense, more likely to reach the ground. So the warm air literally is coming up over that cold air, but the actual surface boundary is not moving. So this happens particularly in the wintertime, and all year long you'll find these fronts that just don't move. And the reason they don't move is that the upper air isn't allowing them to move. Everything comes off of the upper air. So if we look at that, here's a warm front, warm flare moving north. Basically, if you're at a station that's right in here and this front passes you, winds will shift to the south probably or southwest, and it gets warmer. Notice on each side of it, the pressure is higher. The fronts always get a little bit lower pressures right by the front. So here is a cold front. Air is more dense. They're more steep. They tend to have a lot of the precipitation right along the very edge of them, even in the warm air. Here is a backdoor cold front. Most cold fronts that we look at come in from the northwest, drop southeast across the U.S. However, once in a while they come down in the East Coast, and they can also do this in the Rocky Mountain area. They kind of move to the southwest with time. This kind of a front, when it comes in here and the Appalachians gets locked up, you can get lots of cold air on the east side of the mountains, not that much on the west side of the mountains. So occluded fronts, basically they're where a cold front has taken over another cold front, pushed the air aloft, would be a cold occlusion, or cool with a warm type, where you have the warm air aloft as well. Still cool air coming in, pushing out the colder air. So these basically happen near a strong low pressure system. Here's the Norwegian cyclone model. We start up here. The first thing you find is a weak low developing. Aloft, there's divergence. Many of you put about troughs to the northwest of it. Yeah, but they trigger divergence in this area, right in here where this low is developing. The trough gets deeper, pulls in more cold air. Notice the temperature contrast. Extratropical type zones have extreme temperature contrast across them. Sometimes 50 to almost 70 degrees at maximum times or more. So that is one of the things about an extratropical cyclone that differentiates it from hurricanes or anything like that. They have extreme temperature contrast. Think about it. When you have a rainy event up there, clouds come through. Many times there's a low moving by. You may get in the warm sector shortly, but you'll probably get a cold front that's passed through. Sun comes out. That's an extratropical low. They happen all year long. And you can see here it just talks about the birth of it. You get a little bit of temperature contrast, gradually develop a calm ahead, and then gradually, even a dry slot forms to the west of it many times, moving in, taking out the rain, like right in this area right here. That's one of the hardest things to forecast as a meteorologist, because if you hit that dry slot's going to cut off your precipitation. You may actually get a little bit warmer and get some sunshine there, where you may have forecast a rainy, cloudy, cool day. And eventually you get the occlusion. This is a conveyor belt, basically showing you there's a warm conveyor of air coming up out of the tropics. Usually rides up low levels, eventually coming up to the northeast. There's typically a cold conveyor belt coming out from Canada or North Atlantic. Then there's a dry airstream further to the northwest. They all merge together to bring the extratropical cyclones that you're seeing right here. One of the keys with them is trying to forecast which side of the extratropical cyclone you're going to be. So if this was moved over Columbus, for example, if one day you're forecasting the low to go to west of Columbus, Columbus is going to be in the rain, warm sector at wintertime. We'll say it is winter. Now, say all of a sudden, we're forecasting the low the next day to go east of Columbus. All of a sudden, Columbus is in the cold sector, and maybe they're looking at a foot of snow, where the day before they were looking at all rain. So you see, just moving this low, maybe 50 to 60 miles, may make a huge difference in the kind of precipitation you wind up with. And you can see all the various tracks of low pressure here. And a lot of the bigger ones, obviously, you think about it, if you're coming out of Colorado, you're pulling up air coming up from the Gulf of Mexico into it, whereas the Alberta Clippers tend to stay well to the north. Not a whole lot of moisture available to them, but tend to be pretty doggone cold. So, cold core systems, which is what the extratropical are. Temperatures are going to drop with height. They get colder and colder the further you go up. And because they're denser, the pressure changes very quickly, so you wind up with low pressure aloft as well. And when they're not that strong, maybe they tilt back to the northwest. Warm cyclones, on the other hand, are just the opposite. Remember, if you have a warm cyclone, forms generally over the desert from the heating, and what happens is, as you go aloft, because it's warm, the pressure is actually going to change slower. You actually wind up with an anticyclone aloft. So high pressure systems develop, basically, they develop like over the Arctic and over the tropics. They develop huge air masses, and we've just talked about the air masses. The air takes on the characteristics that are under it. That high doesn't move air around much, so it gradually warms it up, and you can have warm highs as well. There are some other local circulations that occur. Lake Erie, for example, would have a lake breeze, and a land breeze. You get circulations in the mountains. If you go out in the Rocky Mountains, you get different circulations, and these circulations are something that fire people deal with all the time when they're fighting forest fires, because they've got to understand how the wind is going to blow that fire. Chinooks coming down off a mountain. It's a very stable atmosphere, and it does not continue rising, just the air drops and warms. Some of these occur out in the Rocky Mountains. Some have come into places like Cheyenne, Wyoming, and raised the temperature from 0 to 70 within a matter of an hour. There have been some extreme temperature changes, and they're very dry because they're coming down. Santa Ana winds are kind of a Chinook in a way. They come down into Los Angeles, and they can get very, very strong, very hot. Think about it. They're dropping down, coming from a higher elevation to a lower one. They're getting compressed. They're warming. They haven't changed the amount of moisture in. So what happens is warm air can hold a whole lot more moisture. They get drier and drier as they reach towards the ground. There's katabatic winds, desert winds, dust devils that occur, hubbubs. Believe it or not, you get those down in Phoenix. I've seen some down that way. Heat burst. Think about if you get a rain shower and all of a sudden the rain dries up pushes the air comes down, it's still compressed and warm. It can actually raise the temperatures at the surface. So with this, let's take a look. Here's a surface weather map today. We have low pressure, weak one right here over Minnesota, another one over New England. And if you were to look at GOES this time, there's your low pressure out in the Midwest. You can actually see like a comma head to it almost. Definitely can see one developing here as it's getting more and more wrapped up, heading towards occlusion. Here's your moisture. This low is pulling up moisture at the low levels coming out of the Gulf of Mexico. And you can actually see the low clouds moving north towards this low pressure system, which will help its rain later on. So we're looking at that low that was up over New England. Look at the jet stream. I want to go back here just a second. If you look where the fronts are, there's one that went way down, but look at them all now. Up here, all to the north. If you look at the jet's way up north. And it's not sinking into the U.S. yet. So this one has very strong divergence on the right rear. And the left front actually has double divergence, so it's going to continue to get deeper. So if you were to look at these in a forecast, so if you just wanted to look at what the jet stream was going to do, and this is a model forecast, so it's not always going to be perfect. But notice the strong cold fronts are going to stay up in this area, right along the jet. So you never really get a tremendously deep cold front driving to the south. You get some coming down a little bit, but they're always getting kind of just staying across the northern half of the U.S. And you can see this pattern just stays. And this is through Monday. One of the things to notice is these jet streaks, very strong wind in here, and they may initiate some weak low pressures along this cold front that's up here. So every time you see these stronger winds coming in, moving in, they might help to generate some low pressures here. But what you're really seeing is that the real Arctic, real cold continental polar air mass is hung up and is not able to get into the U.S. at this time. Here's another little dip coming down here that might help bring it a little bit further down into the plains. And here comes one. Notice how the wind shifted to the north here? It's really trying to deepen. It's making it a meridional trough instead of what we're looking at more of a zonal flow. Look how much deeper it looks. That's going to pull up a lot of warm air, but it's also going to pull down a lot more cold air. So be interested to see how all this evolves throughout the week.